Good day, ladies and gentlemen, personalities. Today we are going to be speaking about compound angles in trigonometry. All right, so basically, ladies and gentlemen, personalities, the compound angles in trigonometry is for a grade 12 maths syllabus of CAPS in South Africa. So if you are doing grade 12 and you are doing pure maths, then you will come across questions that has to do with compound angles. All right, so ladies and gentlemen, personalities, there are formulas of compound angles that you use, and basically in compound angles specifically, the most important thing that you need to know is how do you go about using compound angles. All right, we will later go and look at how they are developed so that you can have that knowledge as an extra. And then sometimes it does come a question that will need you to have that understanding, but the biggest part of it is simply to know that how do you use it. You must know. So number one, you must know compound angles. Number two, you must know how to use them. Okay, but you don't have to cram them. You just need to know them and know how to use them, because you will always be provided with them in a formula sheet in the exams and tests. All right, so when you have compound angles, the first one is this one. You've got sine A plus B, which is equal to sine A plus cos B plus cos A sine B. And then you've got the second one, which is sine A minus B, which is sine A cos B minus cos A sine B. And then the third one is cos A plus B is equal to cos A cos B minus sine A sine B. And then lastly, cos A minus B is nothing other than cos A cos B minus sine A sine B. Right, now how do they appear in tests and in exams? So the uses of compound angles. So you use them in two cases. So case number one is when they say simplify. You can be given a problem and then they say simplify. Most cases they will say without using a calculator. Okay, and then you will see one of those examples so that you will see how it appears. They will say simplify without using a calculator, and then in that particular case you will need to use a compound angle. Okay, or they will say evaluate. They will say evaluate a trigonometric function, and then also they will say without using calculate, and then that is basically where you're going to use compound angles. Okay, so let me give you an example. Okay, so let's say you are given, they say simplify without using a calculator, and then they are giving you something like this one. They give you sine 20 degrees cos 40 degrees plus cos 20 degrees. And then sine 40 degrees. So you need to simplify this without using calculator. Okay, if you had a 30-degree angle here, you will know what to do, because you can be able to find the sine of 30 degrees without using a calculator. But now you are giving sine 40, and then there's cos 40, there's cos 20, it's just a mess. So what do you then do in this case? Okay, so you can see there are two trigonometric functions here, and then there's a plus, and then there's another two trigonometric function here. So in your mind it rings that in this particular case I may have to use double angles. Okay, Now, okay, so your mind is back to the formulas that are always given on your formula sheet. And then you look, okay, now I've got sine, cos, and then I've got cos and sine. So between the trigonometric functions that I have for double formulas that I have for double angles, which one has sine, cos, and then cos, sine? Okay. You start when you look at the first one, you can see it's sine, cos, and then cos, sine. Okay, and then it's sine, cos, cos, sine, and then here it's cos, cos, sine, sine. Okay, so this one is out, cos, cos, sine, sine. Okay, so this can either be here or here. Can you see that? So you know that you can actually try and replace this with either this one or this one. Okay, now between these two, what is it? And then you have, in order to find that one out, you need to look at the sign. The sign is plus. So here there is, there is plus. Okay? And then so, okay, so that means that this is a double angle formula that you're going to use. Now, these double angle formulas will tell you that, okay, the first one is A and then the second one is B. So, okay, you've got what here? You've got 20 and then you've got 40. So 20 plus 40, what is it? It's 60. So by simply using this formula, you will then know that this is nothing other than sine what? 20 degrees plus 40 degrees. Now what is sine 20 degrees plus 40 degrees? It is simply sine what? Sine 60 degrees. Now when you've got sine 60 degrees, you know you've got a special angle. And then you've got 60 degrees, and then you've got 30 degrees, and then you know that here you've got 2 and then 1, and then you've got square root of 3. And then when you've got sine 60 degrees, here is 60 degrees, it is opposite, which is root 3. So this is root 3 over hypotenuse, which is 2. And ladies and gentlemen, personalities, you are literally done. So if you did not know the compound angle formulas, then you wouldn't have been able to sort out this kind of a problem that you are faced with. Does that make sense? Okay, so you were only able to solve this thing without using a calculator because you had the knowledge of 1, 2, 3, 4 formulas of compound angles. So this is one of the cases where you use compound angles. When you've got a mess like this and you need to simplify it and make it look so simple, then you can be able to actually apply or deploy these methods of compound angles and be able to save the day. Okay? But one other person can say to me, Mkondisi, but maybe you are wrong. Is this really true? Okay, let's check using calculator. Then let's just simply put this thing as it is on the calculator and then let's see what we're going to get as a final answer. Okay? So, okay, here we are. So it's sine 20 degrees. So sine 20 degrees, and then you close bracket, and then cos 40 degrees, you close bracket, and then plus sine 20 plus sine 20 degrees, and then, oh, no, it's not sine 20 degrees, it's cos 20 degrees. Let's go back. Okay, so it's plus cos 20 degrees, cos 20 degrees, and then it's sine 40 degrees, sine 40 degrees, equal to, okay, do you see what we get? We get 0,866, ne? We get 0,866, okay, let's put it here on the side, 0,866, 866. Now let's just put this thing exactly in a calculator like this and see what we get. So we say root 3 over it's gonna be okay. Let's put the fraction first and then say root 3 and then let's say 2. Okay, can you see, guys? It's 0,866. That means this is exactly the same as this one. Which, now what does that mean? That simply means that what we are doing here is correct. Okay, Wonderful. Okay, now this is one of the case. Now let's look at case number 2. Let's say you are given sine 75 degrees. Now this sine 75 degrees, you are told to do what? You are told to simplify the sine degrees without, or to evaluate. You are told to evaluate without using a calculator. If you were allowed to use a calculator, it would have been easy. You'd have just plugged this straight as it is, and then you find what you are supposed to find. But you can't do that anymore. What do you need to do? You need to find another way. So, okay, obviously, guys, you always know that when we want to evaluate trigonometric functions without using a calculator, there's only one thing that we use. And what is it that we use? We use what? We use special angles. So what are special angles? Special angles is 30 degrees, and then it's 45 degrees, and what? And it's 30 degrees, and then we've got 45 degrees, and then 60 degrees. Okay, so here we've got sine 75 degrees, and then we know that 75, so this will be same as sine, and then in the place of 75 we just put what? We just put 30 degrees plus 45 degrees. You can also say 45 degrees plus 30 degrees. It doesn't really matter. Okay, you can just say that. Okay, and then from here, so you've got sine of something plus something. So what is, when you've got sine of something plus something, that is what? That is a compound angles. And where is sine of something plus something? Aha, the first one again. It's sine of something plus something. So if you've got a sine of something plus something, you know you must, then you can have a sine A, sine B, and then plus cos A, sine B. Okay, so in this particular case, we're going to have sine, and then A in this case is 30 degrees, and then cos B, cos 45 degrees. And then there is plus there, so you say plus, and then you say cos 30 degrees, and then you say sine what? Sine 45 degrees. And ladies and gentlemen, personally says, if you did not know how to use compound angles, you wouldn't have known that you are supposed to do something like this, or that you could use something like this. All right, okay, so now you've got sine 30. Okay, what is sine 30? We all know that sine 30 is half 1 over 2, and then multiply by, what is cos 45? You know cos 45 is 1 over root 2. We all know that, 1 over root 2. How did you know 1 over root 2? Okay, you remember there is an angle. There is a 45 degree angle like this. You've got 45 degrees, you've got 45 degrees, and then this is 1 and square root of 2. So when you have cos 45, cos is adjacent over hypotenuse. So adjacent is 1, hypotenuse is 2. So it's 1 over root 2. So that's basically how you found this one. And then plus, and then cos 30. What is cos 30? Cos 30 is nothing other than root 3 over 2. You got root 3 over 2. You can also check that one, and then multiply by, and then sine 45, and then sine 45 is also 1 over root 2. Okay, so you've got a fraction here, you've got a fraction, so you've got a fraction multiplied by a fraction. And then how to deal with that? You multiply a numerator with a numerator and a denominator with a denominator. Okay, so in this case, you will say 1 times 1, and then you'll get 1 over, and then 2 times root 2. The answer is 2 root 2. And then plus, and then root 3 times 1 is going to be root 3, and then 2 times root 2 is going to be 2 root 2, And then your answer is, because the denominators are the same here, the denominator is going to be 2 root 2, and then you're going to have 1 plus root 3. Okay, I'm going to leave it here, but you can actually take it over, take it further and simplify it further, and then you get something. Okay, so but I'm gonna leave it here. Okay, so basically you were able to evaluate this sine 75 degrees without having to use a calculator. But what if I'm talking nonsense? What if I'm talking nonsense? You may be talking nonsense. Let's test it using a calculator. Let's look at sine 75. Sine 75 degrees, sine 75 degrees. Okay, you've got something like this, which is not, doesn't look like this, but if you simplify it further, you can actually get something like this. Okay, and then let's do it a decimal form. So in a decimal form, you get 0, 0, 9659. So let me just write it on the side, 0,9659. So that's basically what you get when you put exactly the sine 75 degrees in a calculator. Now let's put this thing on a calculator. If we find something like this, then it means we are right. If we don't, then it means we are wrong. So let's do that. So you've got a fraction, right? Yes, you've got a fraction. And then, okay, let's see. So you've got this fraction, and then you've got 1 plus, and then you've got root 3. Can you see that? And then you've got 2 root what? Root 2 equal to, okay, and then when you do this, 0, can you see that? Can you see what happens? So you are getting 0,965, which is something like this one. Okay, so that means that our answer is correct. So ladies and gentlemen, personalities, this is how you then use compound angles in different formulas. Okay, sometimes you'll be given something like this simplified, and sometimes you'll be solving a whole range of things, and then you will find something like this, and then you need to simplify it and make it something like this one, and so on and so forth. Sometimes you will just have to keep on a lookout. But when you notice this kind of the examples that we've noted here, then you know that you must use what? You must use compound angles. Ladies and gentlemen, this is Mkondes Magaba from Tembela Maths Club, a club that helps learners to understand mathematics. Thank you for tuning in, and have a lovely day, and goodbye.